Hi everyone. As a part of this session, I'll be explaining how exactly you can use a Qemu emulator and configure it as per your machine needs. For example, how exactly you can increase the memory or configure a required memory that is required for your system. And then how also you can increase the CPU core or allocate a different CPU core that is required for a Qemu emulation. That is something what we will look at as a part of this session. But before we try our exercise, we should make sure that Qemu system binary is available that is required for machine emulation. So to check if it is there or not, you run a command called Qemu system, and then you should see so many binaries. If not, may all this binary, at least the architecture what you are targeting, for that you should have a corresponding binary. For example, currently I'm targeting for Qemu system x86_64, and I should make sure that binary for this is available. In case it is not there, you have to install. So for installation, you have to run a command. So that it will try to install all the machine emulation binaries. So currently I've already installed on my system, so it will not install anything. But if it's not installed, if you run this command, you will see all the necessary binaries required for our Qemu emulation is being installed. Once this is complete, you also need a necessary set of kernel and a rootfs image to perform this action. So you have to build them from the scratch. In the coming session, I will explain you how exactly you can build from the scratch. So what I have done is I have set up all the necessary required artifacts in the GitHub. You can download it and you can use it. And there is also a README which explains what all things has to be done. Now currently we will target a single core, and then we will also try to scale up the core one by one, and we will also configure the memory as per our requirement and check out how exactly it would work. The first step what we have to do is we need this artifact. Just try to clone this artifact. I would do it on my system here. So once it is cloned, you'll see all the necessary artifacts being available. One is your kernel image and other one is your rootfs, which is nothing but a RAM disk in my case. So both the necessary artifacts are available for me to do current exercise. Now let us target to run just a single core. To do that, just go to this and just copy this command and you can run it. So now x86_16 x64 machine would start up, and you can see it has started up, and you can also check out single core is visible. And if you see the memory usage, it is around, I had given the option of 512 MB, it is somewhere around there. So let us assume I want to scale it up from 512 to 1024. That is my goal now. So now what I would do is, instead of specifying 512 M, I'll specify it to 1 GB, 1024 MB. Then I would start. So which means I'm starting a machine with the memory available to it of 1 GB. That is what I've configured while startup. Now you can see here, once you start it, you will see here around 1 GB of memory is available for it. So you can check out, you can scale up the memory as per your requirement. But only care you have to take here is it should not exceed your system memory. In my case, let me come out of this. In my case, I have around 8 GB of memory. Okay, I've allocated 8 GB of memory, so I can go max of 8 GB. I should not use full, at least till to that extent I can reach. That is something what you have to take care. It doesn't mean that my system memory is 4 GB and try to allocate a Qemu to run at 16 GB. That's not allowed. So you should be within the limit, within that limit. And you should also give certain memory for your system also. So you should take care of that particular scenario also. That is something which I want to highlight here. Now the next part that comes is increasing the CPU core. Because when we saw the CPU info, right, you saw that it was running only with one CPU core. Let us assume that I want to scale up with two CPU core. Okay, so in that particular case, I have to add one more option called minus SMP, and I have to tell how many number of cores I need. Let us assume I want to run my machine with two cores. I will mention two, telling that I would need two cores. Now, when the system starts, if you look at this, see, CPU core 1 and CPU core 2, both the cores are available. Now, let us try to run with the 4 cores. Now, in this case, it runs with the 4 cores. You can see here, it has run with the CPU core 0, CPU core 1, and CPU core 2, and CPU core 3. 4 cores are fully running in this case. So by scaling the necessary core as per your requirement, you'll be able to configure the machine how you want it to be, mapping to a real system, and then you can run all the kernel scenarios with respect to this. For example, let us assume you want to simulate some SMB scenarios, SMP scenarios, or multi-core scenarios. You can mimic all of those by setting the configuration here, as you can see in this particular case. That is something which I wanted to highlight here. Okay. So then this is the main part which I wanted to explain. I suppose you have all the info for you to scale up as per your necessity. You can try it out. And if you have any questions, you can get back to me. Yeah. Okay, then fine. Bye.